I confess, word problems when I was a student really confused me. Let's go ahead and work through this intuitively and then kind of algebraically to see how they work. A scientist is testing different chemical reactions. She starts each substance at a temperature of 40 degrees. That's going to be important. And she wants to find reactions in which the temperature change from the start to end is less than 12 degrees. So it's either 12 degrees hotter or 12 degrees colder. What do we have to do? Write and solve an inequality to show acceptable final temperatures. Well, let's just first of all do this intuitively. Intuitively. Okay, I'm going to draw a picture to help me understand. I'm starting at 40 degrees. I have to have a change of less than 12 degrees. So if I have a change in the positive direction of 12 degrees, that puts me at 52 degrees. And if I lose 12 degrees, that puts me at 28 degrees. And if I want less than 12 degrees, that means I could have 11 or 10 or 9. That means I'm looking at this 28 degrees to 52 degrees final temperature, which would be A-okay. Anything in this range would be acceptable. Great, that's an absolute value. Now, let's go ahead and think of this algebraically because we didn't write or solve an inequality. We just kind of used our number sense. The writing the inequality and solving it, well, the writing inequality is the hard part. The solving it's the easy part. This is where we're going to do a little bit of guess and check. Okay, what would this look like? Well, I'm going to say, I'm actually starting at 40 degrees, but let's go because everything that I've been working with thus far is starting at steps away from 0, not steps away from 40. Okay, so I'm just going to start here. I'm looking at 12 steps away from 0, not 12 steps away from 40. So right now I could say, if I have a number and it's less than 12 steps away from 0, this right here is an inequality describing if I'm starting at 0 degrees, not 40 degrees. Okay, well, that gives me a good place to start. Well, what I have to do is I have to take the 0 degrees start and I have to translate everything up to 40 degrees. I have to move it 40 degrees in the positive direction. This is called a translation. And we've used this word before in math. I'm moving everything higher 40 degrees. Well, let's go ahead and make a guess. Here is my guess. Okay, let's say I moved everything positive, okay, and that has to be less than 12 degrees. Okay, let's start here and see what happens because I translated everything 40 degrees higher. Take a moment and solve this and see what we get. Okay, this is what we just got. X has to be bigger than negative 52 and smaller than negative 28. Well, we did get the 52 and the 28, but I have opposites of what I should have. How is that possible? That tells me that this is not correct. I got opposites. Well, opposites. What happens if I do the opposite here? All right, here's guess number 2 and see what happens. What happens if I take the opposite? I have a number less than 40, and that is less than 12 degrees away from 0. What do we do? Go ahead and solve and see what you get. Okay, that tells us we're looking for numbers that are bigger than 28 but less than 52. That is our answer. So this right here is correct. Yay! Now let's take a moment and say, why in the world do we have subtracting 40 when we were translating everything up by 40? Well, basically this is because we are working backwards, kind of like unraveling an equation. I am trying to find a number, and I knew that I moved it up by 40, but when I'm solving it, I have to move it back by 40 to get it back to 0 in order to be able to solve it. So this is a rule that we're going to see again when we get into algebra, where when we're translating things, we actually do the opposite of it when we're solving it so that we can unwind it to move it backward. So that was a bit of a guess and check. So here is our equation, our inequality that we would write, and we just solved it to get our intuitive answer. Super fun.